going to do streaming now. Just go on YouTube Live and check if there's a voice too. Alright, so we talk about generics, right? So we said the benefit of generic is enabled to detect errors at compile time rather than at runtime. So let's look at an example here. It's say before JDK, right? Like since 1.5, we said before, right? Before we don't have the generics. Prior to 1.5, it's introduced in 1.5. Generics. So before, if we don't have generics, right? We talk about comparable interface, right? Comparable interface. If you do look at the interface Java doc, you see the method interface header needed generics too. T type, right? You may see array list has that too. E stand for element. This is pretty much just, you can use any alphabet, but it's just meaning like, hey, T type. You try to compare two objects with the type that you have to give the concrete type of the object. Now, for a list, this is just the elements type, you know, that you're going to put in a list. Most likely when it's collections like a list, then it is E stand for element for generics. But like comparable, it's not the list, it's just one type, so that's why they use T. Now come back to this. So before, right, prior to JDK 1.5, the interface doesn't need a generics. Okay, if it doesn't need a generic, how would you compare two objects? How would you know that we try to compare an integer to a double, right? Object could have two different types. That's why it could cause an error at runtime, because you compare two different types. That's why if you introduce generics, then you require to give the concrete type in your program, right? Otherwise, the compiler will complain. So that's pretty much the solution, right? It just requires you to give the type. Before, we know that all the Java classes inherited from objects, so that's why we just give the object type, right, as the parameters instead of the generics. And when you pass a concrete type, it just replace T with that type. Like if it's integer, so it's going to be an integer as parameter. Now when you compare to, if you compare to like integer to the string, then it's going to have a compile errors, right? That is two different objects you cannot compare. How would you compare string and to an integer? But if it's an object, you know that Java integer is an object, right? Polymorphism, right? And string is also an object. It still let you compare. No errors at compile time. But when the user really pass an integer and string to compare, then there's a problem. Runtime errors. So that's pretty much why the generic is introduced. That's it. The whole concept of the generics. And then you get a job. just answer just like that. So this is just showing you before and after array list has all the methods. Instead of all the objects, just replace with the E. Okay. Now you understand generics. So let's see. In your test, you're gonna see question like this, right? Are there any compile errors in A and B? See this. This is different object. You see that? You try to add date and add string into array list. That should have no errors in JDK 1.5 prior to, right? Why? Because it's object and both of them are object. But now, since we introduced generics, it's looking for date type, not the string. Then this likely have a compile error because you try to add string to date list. Right, so then we have no problem at runtime. So review the rest on your own here if you have time. Now you may see we use the brackets right there. You don't have to keep the concrete type since we already keep it in front when you use generics. This is just showing you how to use the generics, right? Now this one will show you like how could you create a generic class on your own, like if you want your class to be a generics. Now what would be the type of the class that you want to make a generics? So this pretty much introduces you to CC 202, so that's why I want to cover this a little bit. It's going to be beneficial for you when you get to that class. So it's all about this structure. This structure means a collection of data. How would you collect the data in a manner of you can access or add or remove or update, right, fast. So most likely you want to make a generics to that type of collections, like a stack, right? A stack like a stack of your shirts, right? A stack of books, a stack of data. So most likely stack is very common use in operating system. Or I think this should be a stack data structure. Like you use Word document, right? You see this? The last one that I open is at the bottom of the stack. I keep the file or keep stacking the last. Like this is pretty much the stack. This structure is like first in, last out. It's gonna be at the bottom. Like at the top, pretty much. This is the last file that I recently opened. Make sense? Like if I open save it. Now when you go back, it's pretty much just stacked into. If I try to open, so see the last one is at the top again. If you open another one, it's just pushing this down. So that's the stack that we use in this structure, right? Now this creates a generic stack, meaning think about it doesn't have to be like E in this case can be a file, right? System that I just showed you, right? But stack this structure is always the same. Top, you push is always go to the bottom, and then you keep pushing is put in the top, and if you keep pushing it's moved to the bottom. So meaning it can apply to any objects. Doesn't have to be just a file, right? So that's why I make it generates. You can push, we call push operations, push the new object into the stack. And to implement a stack, they just make an array like list and add. Why we need to make it this way? Let's think about array itself. When you access data in an array, how would you access and find? Like if I want to find like the test summary report, So this could be an array, right? At index 0, 1, 2, 3, 4, 5, 6, right? So I can get to the 6, then I reach the test summary report, right? So can I actually use array list then? Instead of using stack to collect the file here. Now, what happens if I want to add another object? Like when I create a new file, like test2, where would it go? It would go to the bottom, the next index, when you add. So that's why it's not giving me stack format, because I want it to go to the top. So that's why you just have to recoding or re-implementing an array to be a stack format. Make sense? And technically, we just, whenever you add, you add an object, right? Or push, we call push, we add the object. And pop, we just, this is pretty much the key, right? Instead of getting from the bottom, getting from the top, it's just get to the pop means you remove it. You just remove the one from the bottom first, because whenever you add, it's always go to the end. So that's why this is pretty much the top. Let's see if I peak means the top, what's at the top. So it's go to the end of the index, right? Let's see, that's the top. Pretty much just same as list, but what will at the bottom become the top. That is stack. You can see that into a 2. Yeah, it's just like a list, right? Like a list, pretty much just like a, if I keep adding, let's say adding a letter A, B, C, D, E, F, right? Now, F happen to add the last, that should be top of the stack, right? So it was index was 0, 1, 2, 3. Now if I want to pop mean I want to remove F from my list, I have to go to the end of the stack. So that's why I say when you pop, you have to get the element at the get size of the array at -1. Get size 6 minus 1, you get to 5. So that's technically this is the top of the stack, right? Okay, you're just re-implementing the operation to get like a stack. Okay, so now we see when we implement a generics, we return an E type. See that? We pass an E, right, to add in instead. Generics type can also be defined for a static method. So we talked about statics already. We understand what it is. Oh, by the way, static can be the interview questions too. So now let's look at also the test question too, right? You can have the test. So let's look at example here. This is how you do parameterized, but this is a static method. So how would you use print? you can say, hey, this is a generic method. You could pass in any list. List could be an integer list. So when you call, you remember we can use class dot method name. This is a statics. You could make generics by parameterize it to the type that you want to print. Then you can print any list. Then that's the benefits too, right? You don't have to do the what? Overloaded. Right? Overloaded, remember, it's mean different types, right? So now you can just do one and then you can support any types. So this is just a structure to declare static method. Just put the e brackets after the keyword statics right away. Now you may start to see this. E extends geometric object. What's that? So we understand the simple generics, right? E and T. Now you can make it bounded generic type. This is called bounded. So what does it mean? Generic type can be specified as a subtype of another type. Such a generic type is called bounded. For example, we want to create a method called equal area, right? So that it doesn't make sense to pass in an integer for this method in, or string. No, because string and integer doesn't have area. Then we can just make the generics to be only the one that is the geometric object. Is A, right? Extend is inheritance, is a relationship. Only the type that is a geometric object. Right? So be bounded to type. Now, if you pass in different type to use this method, you just compile error. Only the one that has like rectangle and circle is allowed to do that because they have the method get area. So in the test, if you see this, then you understand, right? Because you're going to see extends object. Okay. Any questions? So this is called unbounded generic type. This is called bounded generic types. To define a generic type for a class, place it after the class name. That's what we've seen. To define a generic type for a method, place generic type before the method return type. See? This is just showing the case study. Like if I want to sort, okay, sort an array of objects. So you create an array of integers, array of doubles, array of characters, array of strings. So we have different types. Look, we can support different type with the generics. One method can do all of them. Right, so look at the sort. Sort pretty much just a method. That it makes sense, right? If you want to sort sort require to have compare to, because if object doesn't have compare to, then how will you sort that object? Talk about that. So that's why it makes sense that this object has to be bounded by comparable, and comparable itself also parameterize the type. Okay. So that's an example. Now, what's raw types and what's backward compatibility? A generic class or interface used without specifying a concrete type, called a raw type, enables backward compatibility with earlier version of Java. Right, so the reason why we had to introduce this because JDK being upgraded, right? Prior to 1.5, we don't need to specify, right? It's just like that. This is called raw type. We don't have to give parameterized, right? Which is equivalent to you give the object as the parameterized. Okay, and why we want to do that then is compatible to the some of the classes that we use in JDK is probably developed from version 1.1, so it still support that. So meaning that if you try to use array list and you never give the type, it's pretty much just going to do the raw type for you by doing objects type. Alright, so now let's talk about wildcard generic types. You can use unbounded wildcards, bounded wildcards. So we talked about unbounded already, which is just E itself, right, or T itself. And we talked about bounded already, which is what? E extends. Another like comparable, right? E extends. We also have lower bound wildcards to specify a range for a generic type. So let's look at that then. So wildcard generic types, what is that and why do we need it? Let's look at this example. We have a method, generic method called max. So this one pretty much is gonna take in a parameters as a generic stack. And then it start to pop and you can get the values of the object that you pop. So again, this is new in 1.8 also. JDK 1.8 also introduced that object has the property like double values. Okay. So then you can change it to value in double, right? So stack while it's not empty, we're going to keep to popping the value out. So this is a stack of doubles, right? And if the value greater than max, we just going to say max equal to values. So technically we find the max, right? This one find the max, this method. So now let's see, we start to use it in the main. So we make an integers type. like I said, we should use an integer class when you do parameterized here. Now when you push that number one is actually what? A primitive type, right? An int. So this concept is called auto-boxing. It's going to auto-boxing mean it's going to change into new integer one for you. You don't have to do it here. This is called auto-boxing. If you see the word like auto-boxing in the test, then you understand now, right? And also it's like have unboxing. Unboxing mean the other way around. Sometimes if you want to print integer one, it's going to give you a primitive type one back, something like that. That's called auto unboxing, and that is auto boxed. So you push 2, push -2. Now what you call max in stack is pretty much going to find the max and print it out. Okay. So it said the example defines generic max method for finding the maximum in stack number. The main method creates a stack of integer object, adds 3 integers to stack, and invokes the max to find the max. That's what we see here. So now the question if there is an error here. You think there's a problem here? It looks fine, huh? But it has a compile errors in line 8. So go back to line 8. Why is a compile errors in stack pass in integer number? Is that a problem? Integer extends from number, right? But it doesn't mean that integer is a number for this one, because this is talk about stack number and this is talk about stack integer. They are different things. That's why there's an error. So that's why we introduced, right, the wildcard to solve this problem. So a wildcard generic type has 3 forms. This is unbounded wildcard, the question mark. This is bounded wildcard, right? Bounded question marks to extend from the other type, right? And this is called lower bound wildcard. It's just like vice versa, right? This is just like the opposite, right? Like you already seen that this is like object extend form compatible, right? Then we only want to filter the one that can compare, right? This is just the other way, right? Comparable should be a super of the object. So we know that comparable is a super, right? When we extend, so it's just called a lower bound wildcard. Okay. Any question on these 3 keywords here? Unbounded wildcard, bounded wildcard, and lower bound wildcard. So unbounded is question mark. Bounded is question mark extends t. Lower bound is question mark super t. T is the generic type. So we have to revise our max method, and using this question mark extends number, that would solve the problem. Meaning that because we don't know, right? We don't know that This could be an integer, gonna be double, gonna be big decimal. We don't know what type it's gonna be. So, but we know that as long as it extends from the number, then we will find the max. Then this should be question mark extends, right? Number, right? And that will solve the problem, right? So let's look at how we use the wildcard again. Like this one is going to use a print. So print, we're going to use the unbounded wildcard question mark. When we do this, we probably can print any type from the stack. Right. So because before if we do just what happens if I do E instead of question mark? Will it still work? If I just do E instead of question mark, will it still work? I mean, your question in a test could be just like that, right? If I replace this E, would the program compile without errors? No. Why is not?
Generic stack integer is not the same as generic stack object, right?
So stack.
Kind of the same as the generic stack integer, generic stack number issues we had before.
Right. But if it's E, is it an object? Let's test that then. Because before it is number, so that makes sense because integer is not the number, but now it becomes E, right? Not the number, right? So when you leave it like this, it's just like you extend from object, right? So it say here when you leave it like that, is the wildcard represents any object type. Now if you replace question mark with the object, will it work? We said it would be wrong to invoke print in stack because in stack is not an instance of. Right, because in stack is not instance of generic stack object. Because in stack is an instance of generic stack integers. Right, to replace with object could be wrong. But my question is, what happened if I replace with E, not object, right? Because we didn't say object anymore, we said E instead. Can we do that? So let's try. Generic stack. Wow, it's dependent on another class, right? Generic stack. So generic stack is sort here. Generic stack cell is already E. Alright, so we have generic stack. Can we do like that, right? No, we cannot. So cannot resolve symbol E. So in stack is an integers. Cannot be applied to integers because E is not an integer. A wildcard demo. So if I do integer, that's okay, that's what I want, right? This is just different name. So that's why we want to use a wildcard, right? Okay. Now if I do object, right? Would that be okay? No, again, because we cannot change object to integers, right? because this is generic stack integers. This is two different things. All right. Any questions on wildcard, unbounded wildcard here? Why we want to use that? Alright, so keep going down to another example. For the lower bounded wildcard, right, question mark super T, when do we need that? Look at this example. We have two stacks, stack 1 string, stack 2 objects. We push string to stack 2, 2 to stack 2, because it's object, right? It could be string, it could be numbers, right? Now string to stack 1. And we have the method add, and add pretty much is going to combine, right, create a new stack, or actually combine stack 2 to stack, push stack 2 into stack 1, right? Where will the content combine stack, right, by removing stack 1 contents within stack 2. Alright, so would this program has an error or not? That could be a question of the test, just like that. Again, this one we said stack 2 the super type of stack 2 right, super type, the question mark is a super type. So if you go back to the previous one, right, we look at, in this case, right, so we have integers. We said integers extends this super type, right, which is a number, right, and this one whatever it is, when you parameterize to use, like add, in this case, when we use add, we didn't give a type, huh? So if we didn't give the type, so T is going to be because when you call static, you can parameterize it, right, to use. In this case, it didn't give a type. Add, let's just call this add, because it happened to be reside in the same class, right? So add, so T, so now T actually comes from stack 1, so it's going to be string, right? So this is going to be string, so this is going to be string then, right? And this is going to be string, right? And question mark is going to be object, right? Because this is an object, right? When we do stack 2. So what does it mean? Super type is an object, right? So that means when you keep popping and pushing into stack 2, would that be possible? Since stack 2 is an object, then this should be fine, right? Because this is a string. And it's a, if you can rewrite the headers of the add to use question mark extends t stack 1 and then t stack 2, this still gonna be working. It's also work. So let's look at the chart here a little bit. Inheritance relationship involving generic types and wildcard types. So this is object, right, class. E is the generic types, right? So we could use the wildcard. We could use question mark super E, right? Lower bound. Yeah, this is lower bound, right? And this is E superclass. Yeah, this is pretty much E superclass, and then this is E, right? So this is pretty much just a super of E. The boys try to say here, right? And this is just extends from E when you use an E subclass. So whenever you want to refer to a parent of E, we just say question mark super E. Like this is the parents of string is object, right? So that's why you can add technically this is already string, so it should be fine, right? And when you put, in this case, t becomes object, right? So this is showing, you could use question mark, and this is question mark extends B, and where's B? So this is the B, right? So this should be question mark super B, right? B subclass. So that's pretty much all the wildcards there. Any question on wildcards? Alright. Restriction on generics. Ensure and restrictions. So information on generics is used by the compiler, but it's not available at runtime. Oh, this erasure, sorry, I thought I said erasure. Erasure and restriction on generics. Again, it's the information on generics is used by the compiler, but it's not available at runtime we call type erasure. Generics are implemented using an approach called type erasure. The compiler uses the generic type information to compile the code but erases it afterward. So that's why I call erasure. So meaning that the information is not available at runtime. So this approach enables the generic code to be backward compatible with the legacy code, right? To make it support the previous one. So the generics are present at compile time. Once the compiler confirms that generic type is used safely, it converts the generic type to a raw type. So for example, the compiler check, this is using generics. So this is good because it is string, right? Now it's going to convert back. Type happen to be erased. And then it's just cast because it's going to be an object when you get 0. Okay. So when generic classes, interfaces, and methods are compiled, the compiler replaces the generic type with the object type. Correct? So for example, so we have method print. So these are generics. So after compile, it's going to replace E with object. And the reason is to support the legacy code. Let's look at the bounded type. So we say E extend geometric object, right? So say the generic type is bounded. The compiler replaces it with the bounded type. So echo areas here is bounded to geometric objects, right? So that's why it's replaced with geometric object type right here. Alright, so it's important to note that a generic type class is shared by all its instances, regardless of its actual concrete type. So list 1, string list, list 2, integer list. Although array list string and array list integer are 2 types at compile time, only one array list class is loaded into JVM at runtime. List 1, list 2 are both instances of array list. So if I say list 1 instead of array list is true, list 2 is also instead of array list. They don't look at the parameters, right? Parameterized, no generics at runtime. So if you say list 1 instead of array list string, it is wrong. Like it never started as like that in JVM. Okay. So just keep that in mind that generic types are always erased at runtime. You cannot use new E like that. You cannot use new E for array. No. You cannot. Let's see. You can circumvent. Right. So what happened, right? Like if I want to do generic array, how would I do that? So since you cannot use that, you have to do a new object array you can use. Then you're just casting it instead to be an E array type. However, when you cast like that, it's causing an unchecked compile warning. The warning occurs because the compiler is not certain that casting will succeed at runtime. Is unavoidable then, in that case. Right, because when we cast, we know that this is going to be an object of string. Right, E. Example, if E string new object is an array of integer objects, that will cause the cast exceptions. And that's pretty much unavoidable in this type, and yeah, that's the limitation of Java generics. So with this wrong, so you said you create an array list equal to new array list, and you parameterize the list to a string, and then you also give the size to 10. No, you cannot do that, right? This is like you try to create an array of array list by using generics. So this is not allowed. To do that, you actually have to create an array list 10 first, and then you just need to cast to be an array of a string instead. But you will get a warning. Just the same problem here, right? The typecast, we don't know at runtime. A generic type parameter of a class is not allowed in a static context. Let's see. Since our instances of a generic class have the same runtime class, the static variables and method of a generic class are shared by all its instances. Therefore, it's illegal to refer to a generic type parameter for a class in a static methods field or initializers. For example, so we have test E class. So E, this is static void ME. So when we say static, it should be shared, right? And then this, when we say statics, so it's going to be shared, the method will be shared by all instances, right? We pretty much just say test.m, right? So this will not be valid in that case. Like statics E, because it has to be shared, so that's not valid, even in a static context. Let's look at exceptions. We're gonna talk about exception next, right? So this is much at the end of generics anyway. Okay, this is to show you a case study. So let's look at, it's the exception classes. So what's exception classes? So exception, pretty much in Java we have one exception class, and if you want to implement your exceptions, you could by extends from the exception class. Okay, and exception class is cannot be generic. You cannot make a generic like that in a new class when you extend. This is just show you this is an application create a matrix and use it generate. Okay, so that's just a case study that I want you to pretty much go and review on your own on that one. So we pretty much at the end of Generate chapter 19. Any question on that? Okay, like you can see we have one section, 10 questions on that. Okay. Yes, 10 questions. Now let's talk about chapter 12. Okay, we talked about 13 already last time. 19 done. Chapter 12. This is exceptions. So come back to when I start class, I asked you who used exceptions, right? So why do we need exceptions? So now we understand why we need generics, right? Enable compile times errors, right? Instead of make it at runtime. How about exceptions? So exception is pretty much just you try to run your applications, right? And if you don't have exceptions, it's going to, if there's an errors, right? If there's something causing the program to terminate, then the user pretty much just going to have that exceptions. Like it, when you have exception, it's pretty much just tell the user like what happened to the applications if you handle it. Like for example, when you use Microsoft Windows operating system, right? So you see that sometimes it says send report to Microsoft. That pretty much just it happened to have a runtime errors, and then instead of terminating the program, right, it's actually handled by pop up the message for you to send a report, and the program's still running. If you don't have exceptions, what happens? Think about, I create an array size is 10. So if I try to add the elements to array more than 10, you will get array index outbound. That is an exception message. From the error message, that's exceptions. Typically, if that application is running in the real program, the application is going to be terminated, right? Which we don't want that to happen to the user. We talk about index outbound exception. Happen at runtime. We don't want that to happen. So how are we going to handle that? That's why we're going to have try, like we introduced this chapter, right? Exception handling. Like now we get index outbound, we never handle it. Now you get a chance to handle it. You could handle by your program can just create a new bigger size of array, make it like an enlarge method. So whenever you get to that, it's just increase the size. Then the program will never terminate, right? So that's how we handle it. Like there are many ways to handle. So that's just an example. So let's look at just basic first. Go with the basic. So it enables a program to deal with exception situation and continue the normal execution. That's the point of exceptions. Like generics actually try to prevent errors at runtime by catch at compile time. Exception pretty much enable program to deal with exception situation pretty much at runtime, right? How would you deal with that if the errors happen at runtime? That's exceptions. And then the program still continue, right? Without exit. So runtime errors occurs while the program is running. If the JVM detects an operation that is impossible to carry out, like you access an array using an index that's out of bounds, I just show you that example, or you try to divide it, like user try to divide it by 0, that's also arithmetic exceptions. I have the calculators, I never taken care of input validations, user put 0 in, right? So program terminate. This one also show if you enter double values. This is happening all the time when you scan it, right? If you do next int and then user input a string, then or double, then it's gonna be type input mismatch exception right away, and then program terminates, right? So runtime errors are thrown as exceptions. An exception is an object that represents an error or conditions that prevent execution from proceeding normally. If it's not handled, program will terminate abnormally, right? So that's why we want to handle. So let's look at exception are thrown from a method. This is an example that I said I try to divide by 0, right? Quotient. So this one run normally if we never put 0, right? This is just simple program. But when we put 0, we get arithmetic exception right away. Try to divide by 0, errors. So how are we going to fix that? We said very common then. Put if else surrounding it then. If the number denominator is 0, then we going to print statement like divisor cannot be 0. If it's not 0, then we just let it run. So that is very simple to handle with if else, right? Now we actually could modify this a little bit, right? This program to pass two numbers into the methods. Make a method for that, and do the same. Check if 0, divisor cannot be 0, and exit right away. Otherwise, just return the result. And the main pretty much just call the quotient. We just modify a little bit, right? That would help take care of that situation too, right? Just make a method for that. Now, let's look at if number 2 is 0, it cannot return a value. So the program is terminated at in line 7. Say line 7, right? So you think you want the program to terminate right away whenever the user enters 0, or you still want the program to continue? We actually still want the calculators to continue, right? When you use calculator and divide by 0, right? So that means if else doesn't help, right? Because if only check, hey, when it's 0, it's just exit the program. When it looks like it can solve the problem, but it just say, hey, you cannot divide by 0 and exit, right? So that is actually a problem, right? You should not let the method terminate the program. You should decide whether to terminate or not instead. Right? So how are we going to do that? That's why we have to use the exceptions, right, to help. How can we modify, right, the program, right, to use exceptions where exception has occurred. Let's see this program. So instead of when it's equal to 0, so we can just say throw new arithmetic. So we have the word throw exceptions, new arithmetic exception, divisor cannot be 0. Alright, so the methods when you write exception, the method has to throw instead, right? Like before, when it says 0, you just make it print and exit. That is terminate right away. Now we're not going to terminate. We just throw, meaning I'll let the main handle it. Right? So the main, how do the main handle? Try. We try to call the quotients. If there's no problem, then it's going to return result. But when there is a problem, when we catch, like in the term of divide by 0, arithmetic exceptions, then how would you handle that in here? Right. You may handle to print the message. You cannot divide by 0. After it's print, the program still continues. It never terminates. It never make it exit. Right. So it just do this statement, and just like if else, right? It still continue. That's it. To the next statement. But if you do if else, it's just terminate right away, right? Even you just say to exit, it's still terminate because there's an error. But this one, we will not terminate. So that's the difference between try catch and if else, right? We're not going to terminate the program. So that's important. Just like when you use operating system Windows, you see that program never terminates. You just send error message, you still can use Windows. They use exception handling. And that's what you want to introduce into your program. Alright, so let's understand the try catch. Right. So you can see a lot of this question on your test. It's just one chapter, right, dedicated to that question. How many? 10 questions. Talk about try catch. Okay. So when exception is thrown, it's thrown from where? From the method. So that's why we want to create a method when you're dealing with exceptions. Okay, just dealing with one task, the method, like to do 5 quotients. And if there's an error, we throw. When throw an exception is passed exception from one place to another place, which is to the main program if the main is using it. So the statement that invoked must surround by should contain the try catch. And the one under the clash block pretty much just do the handling. This is a cache block. So a cache block pretty much has the exceptions as the parameters, the type of exceptions. Like in this case, the divide by 0 is arithmetic exception type. So that's why we just pass in the type. So this is just try to show you, right, throw cache block. So now you see advantage of using exception is enable a method to throw an exception to its caller. Caller pretty much the, like in the main you call quotients, right? enabling the caller to handle the exception. So if you don't have this capability, you either have to terminate the program or the method's questions has to handle by itself. And it does make sense to let the method doing that, the one who call and use it should handle it. That's why the method should throw it. Like the one cause the error should handle it. So this is showing another example for the input mismatch. Like I told you, like for the scanner, if I do next in, and the user try to put something else like double, it should, you try to do this. If there's a problem, you catch and then you handle it here. Try again, incorrect input. So this program will never terminate, it's still in the loop. But if you don't use try catch, you use scanner, try to put in double, it's going to accept an errors right away and program terminates. Right. Alright, so now this is exception types. This is also important. So let's look at, it's just showing the hierarchy of the exception classes in JDK, in Java API. So we know that throwable extends from object. So exception is starting from throwable class in Java. So throwable has exception and has error classes. Error has linkage errors, extend from errors, and virtual machine errors, and many more error classes. Now exceptions, this is a part that we learned in this part, right? We have class not found exception, IO exceptions, runtime exceptions. There are many types of exceptions. So IO exception we gonna learn when we try to read text, right? Input and output, read the file, and what happens if the file is not existing, then we throw exception. When you write something to the file, like save the file, is not existing, then we throw exceptions. Now class not found exception you already seen when your program tries to refer to another class and that class is never existing, maybe never get imported into the program. There's no exceptions. And we have runtime exception. We already seen that, like extends from that is when we run the program try to divide by 0, that's arithmetic exceptions. No point exception. When do you get no point exception? Anyone? Right, object never do the new instantiation and you try to refer to it. We see index outbounds arrays, illegal argument exceptions, and so on. So throwable class is the root of all exceptions. System errors are thrown by the JVM and are represented in the error class. So error could be inter-system errors. Those are rare. And if that happens, you cannot do anything because it's happened to be a system. So But if there's an exception that cause from the program, you could handle it. So subclass of errors could have linkage error. A class has some dependency or another class, but the latter class has changed incompatibility after the compilation of the former class. Virtual machine errors. The JVM is broken or has run out of the resources, so it needs in order to continue operating. So if you happen to see those type of errors, then you know that what happens, and you cannot handle anything much when you get those errors, because it's probably you have to deal with the hardware or libraries that you're missing. Now this is exception that we can handle. Right, so we talk about class not found, the class doesn't exist. Make sure you found a class, import a class to handle that, right? I/O. So we talk about when you want to read and write a file, and files never exist. Runtime, you've seen it. These are part of runtime exceptions. So a method is passed an argument that's illegal or inappropriate, so we get illegal argument exceptions. Alright, so let's look at a handle. So the main concept of exception is right here. Like when you try to invoke the method, like this is like a chaining, right? Method chaining anyway. Like this could be a main method, right? Or another method try to invoke another method. That's possible. So you want to catch exceptions inside the caller, right? So this method just needs to throw add the text throw on the top to declare an exception. So pretty much when you want to use exceptions, you need to declare try catch, right? Exception. You want to declare throw exception on the top of the methods, and you want to throw when the exception occurs with the instantiated object of the new exception class. So let's look at example. So this also the catching, you can catch more than one. Okay. The first one that catch will pretty much just result in the handle first. Like for example, so methods one method invoke method one, right? In a try catch, exception one will happen. Method one also invoke method two. Right, exception 2 will happen, and this is method 2 also invoke method 3 with exception 3. And then in method 3 we make it throw exceptions. So this is the main method. So it's going to use stack to help, right? Pushing until the end, and then you pop and execute it. So this is just the chaining that we see here. So meaning that when you use method 1, you're supposed to surround with try catch. So, and the same thing. Now let's look at, we know that runtime exception is what? Inherited from exception class. So can we do this? Since we said we can handle different exceptions, can we say catch exception first before we do catch runtime exception? I'm not sure if this on the test, but it could be. Yes? Who said yes we can? Who said no? I'm sure you're not going to say anything. No. Oh, you cannot see, huh? The reason is there's an answer there. Alright. You see the answer? You cannot do that. Why? Because there's no reason to have this. Because this is subclass. When there's an error, it's going to handle that right away. And then that's it. The reason we want to do multiple catches because we want to get into the details as much as we could. Right? And the one that we cannot, then it's just going to handle outside. So this is the correct orders. Now, when you write a method, if you want the method to handle, which one you're going to choose? A or B? To handle exceptions. A, right? You try if there's an errors, then you catch and you handle inside, right? You implement how you handle it. This one, when you write, you pretty much not handle. You just throw, when there's an error, you throw an exceptions. Meaning that the one who called P1 has to handle it. Like the main has to handle it if main call P1 by using try catch. So that means you don't have to handle it. You can just throw if you don't know how to handle it. And it's very common that we throw when we create the API, right? Like you see when we talk about text IO. Now we see that there's a parameters IO exception EX. These are the classes, so you should have a method, right? Like you can have a method like get message, print stack traits. So that is pretty much just get information from the class. Okay. So what's that like? It's pretty much you already seen it when you have an errors. It's print the stack trace for you where the errors start in what line number. That's why you just trace back. You already seen it when you compile the program and it has an error. So this is just an example. Like I told you, seen that, right? Arrange index outbound 5. See, and what line of code create that. So that prints stack trace. Get message. That's the message. 5. 2 strings. Return the object back. Get stack trace. So this is showing you, right? So when you handle, you get, right? So we try to print an array, right? So sum, right? Find the sum of an array. Pass the array in object. And if there's an error, so we could just do ex.print stack trace to see the errors. Or you can get the stack trace and put into stack trace elements. Pretty much you use this to trace back how to fix the errors. So we use that a lot when we want to create a log file, right? Like what's that log file? I mean, when you do like web application like Blackboard, has an error yesterday. It was down. You know, right? If you use Blackboard. So Blackboard pretty much use Java. But how could there's an errors? We don't know. Just like operating system like Windows, they don't know. The user may happen to do something and create errors. How would we know? We surround with try catch right there. Right? If the user try to log in, maybe that caused errors. Or the user try to upload something like me, I actually try to, sometimes I download something so big, so it's pretty much just make the server down. You crash it. So that's why Blackboard using Java, and Java is not a good tools when to support, like, you know, many people use Blackboard, right? All the students. So I was thinking when they used to call me for interview for a job Blackboard, I try to tell them what's wrong with their system. And then they're not interested in me anymore. Because Java is very expensive. It's down. You see it's down all the time, right? Yeah, but anyway, what they're gonna do, developers, they're going to go to a log file. A log file, they pretty much just they surround with the try catch, and there's a problem, they just log with the stack trace right there. Okay, but I can tell you most likely the problem is just from the memory issue, because I have experience using supporting like casino, slot machine. Yeah, use Java and it's down all the time. So that's why Google, Facebook, they use Java. Twitter don't use Java. If you want to do like support in the higher level like that, you don't want to use Java anymore. They write their own program. They use their own program. They create their own. Like Angular, right? Who create Angular? This is Facebook or Twitter? I think Twitter. Microsoft just use it. Alright, so this is to show you an example of how to use them all together in a program called circle with exception. So let's look at this example. It's going to help. So before we create a circle with radius, right, number of objects, right, and that's constructor set the radius, right. Now this is called the default constructor, called the one that passes the radius, set the radius. Increment number of objects, keep tracking how many circles created, get radius, set radius. Now set radius, normally this is a place where you should put, right, exceptions. Why? Because we want to make sure that circle should not be a negative numbers radius. If you don't check exception, what happens? User can just put the negative numbers in and the program still run, but it's going to create a problem at runtime, right? So that's why we want to surround with, just though, because we not handle it. Set radius is not going to handle it. Let the user handle it. And that makes sense why you want to though, you don't want to handle here, because you are not the one who use circle. You only create API. The one who use API like circle should handle like how they want to handle in the case of negative radius, right? You don't know how. So the main application should know, the one who use it. And this is how you do, right? Check if it's greater than 0 is fine. Otherwise you throw it. and then the method header just use throws with the exception name illegal argument exception. Alright, so let's look at when we start to use. This is how we handle it, right? In the main, you have to try and catch when the exception occurs, just print, right? Alright, so that's just an example on try catch exception. Now we also have finally. So the job interview always asks this one. I get this question very often. So what's the difference between final, finally, and finalize in Java?
It's always executed regardless whether an exception occurred or not.
For finally, yeah, always executed. How about final?
What's the difference? That if that exception, like there was an exception that it would not occur. Final is a modifier, right?
Final is the modifier. You use that all the time. What is that? Constant. When you create constant, you use final. Final int interest rates. Right? That's it, that's final. How about finalize? Finalize, right? It's a method that's called in the JVM. What does it do? Clean up the memories. Finalize is going to clean up. Remember when you instantiate object, every time it's going to allocate memory in the RAM. What happens when you don't use it? It's still in the memory. That's why Java is so expensive in the memory. Because people rely on JVM, Java Virtual Machine, to clean it up. So finalize pretty much just try to clean up all the garbage collections, the memories of the, like when object never used for a long time, it's going to clean up because it stay in the RAM. So it's called, right, garbage collections collected to an object. Here, right, finalize is in the Java doc. So if you look at, it's part of object class. Object class has finalize, called by the garbage collector on an object when garbage collection determines that there are no more references to the object. A subclass overrides the finalize method to dispose of system resources. Now you know. Go to interview and get a job. Final, finally, and finalize. It's a very common question. These are common, I'm telling you. I see this question all the time.
You just have a class. That's okay. It's just you giving us tips on like how to prepare for computer science jobs.
Yeah, I can have that. I can have that, I'm telling you. Yeah, I have, a lot of people have the job. I mean, we do on outside. Yeah. I'm not a dean, so I'm just professor. Teacher. I'm not the one who said I should offer. But yeah, I used to do like outside. I offer courses. Yeah, like I have like only 16 weeks you get a job. Something like that. If you don't get a job, I offer you a job. Maybe a lot of people will enroll, right? So I find that it's kind of hard to recruit students. Yeah, because sometimes when they get to one point with all the coursework, they cannot handle it. You have to work hard to get that. Yeah, but yeah, I think I know what they're looking for, and I know exactly what question they're gonna ask you. Yes, in the test, right? This is gonna be in the test, right? But some of them are not. Like finally will be, finalized will not, because it's not related. You have to know finally. Try catch finally. So it means that you try, right? If there's an error, cache gonna handle, right? Now, no matter what, it's to execute regardless whether exception occur or not. Meaning, if there's an exception, it's going to do this, or if there's no exception, it's going to do this. Okay. When to use exceptions, you already know it, right? I tried to tell you, right? You should use when you want to handle, or you want to, like, you're not sure if there's an error and you want to keep tracking on that. So this one said method should throw an exception if the error needs to be handled. So let's look at this one. It said an exception occurred in the method, right? If you want to the exception to be processed by caller, you should create an exception object and throw it. If you can handle the exception in the method where it occurs, there's no need to throw or use exceptions. If you can handle, then you don't have to use exception. That's it. If you cannot handle, so you throw and let the caller handle it. Like for example, should you use try catch or if else? So this is pretty much an instant up object, right? Like we get new part exceptions if it is null. In this case, you know how to handle it. You don't want to deal with the null pointers, then you said if it's not null, then you get to a string, else just say refer var is null. Then in this case, you don't want to use exceptions. Okay. Rethrowing exception. Okay, Java allows an exception handler to rethrow the exception if the handler cannot process the exception. Like you handle, you process is throw. If the handler cannot process exceptions. Or simply wants to let its caller to be notified of the exception. So it's allow you actually throw again, right? You're supposed to handle here, but you throw it again. And then you pass the object, like exception. Okay, let's say support statement 2 cause an exception. So it's going to catch and throw exception again, right? chain exceptions, throwing exception along with another exception form a chain exception. So this one main try to call method 1. If the cache errors is going to print stack trace. Now method 1 throws exception because if the cache errors is throw again, right? So that's why throw exceptions. Cache error from method 2. Method 2 also throw exceptions. So this is like chaining exceptions. Alright, so we've been using exception classes from the Java API, right? You can also create your own exceptions class. So pretty much just extends from exceptions. Right, inherit from that. Like, for example, you want to handle when radius is invalid. So you can just say invalid radius exception, extend exceptions. And what you need to do pretty much just the constructor, right? Call the super. Super is just a constructor of exception and put the message of the errors. Like in this case, it's just set the invalid radius with the value of the radius. And the radius, just get the radius from there. So technically just call the constructor of exceptions, and constructor of exception has two of them. One is the default and one of message, and pass the message along that. It's very common to customize your own exception with your own message. Like in this case, after we do that, we just use throw invalid exception instead. Alright, so let's look at, so we pretty much finished learning what is exceptions. Now, we're going to introduce you to how to read and write text file. Okay, so first we have to understand when we're dealing with a file, right? So file system. So Java has a class called file, which going to represent a file. So a file object, right? So file class contains the method for obtaining the property of a file and directory. You can delete the file, you can see the path to the file, you can get the name, you can see if the file is existing, can set to read, write, or can read, check the status of the file, can write. This is the file or directory. This is absolute path. Is it hidden? Get absolute path, right, and so on. Delete, list the file. Look at the last modifier. Pretty much all the property of the files is here. Okay, so now let's look at, this is just showing I want to create a file like image us.def, right? So just create it object name file. Then you can just use other methods, right? And it's just going to print out information about the file. So that's pretty much the file. Now let's look at, we understand the file now, how we're going to input pretty much just read in or write to the file, like in the case of text file, right? So we have print writer class. Print writer is to write. It's very easy, just like system.out, right? System.out you write to where? Console. When you use print writer, you just say object is output, then the rest is the same. Instead of writing to system.out, you say output dot print, right? So system.out.print, just do output.print. Same, print line, and pass values that you want to print. That's so simple right there. And it's going to write to the file. But when you use print writer, you're supposed to give the file that you want to write to. So technically, you just create a text file like scores.txt example like that as an object. And then you can just do output.print. It's going to print to your file. Now one more thing is don't forget to close it when you're not using it. So output.close. So normally if you forget, JVM will close for you, but you just make the memory leak at that point. Alright, so that's how we use print writer to write. So closing resources using tie with resources. Programmers often forget to close. Like I said, don't forget to close, right? JDK 7 provides the following new try catch, try with resources syntax that automatically closes the files. So let's look at this program. So we create the file scores.txt and we say if the file exists, we print file exists and exit the program. Now we try to create object, so to write, and if we success, then we can start to open and output.print and write to the file. And you can see this when you use this try, it's pretty much a resource is declared and created followed by the keyword try. Note that the resources are enclosed in the parentheses. The resources must be a subtype of auto-closable such as print writer. Resource must be declared and created in the same statement, and multiple resources can be declared and created inside the parentheses. You may see this one never called close, right? So after the block finish, the resources close method is automatically called, right? When you just try like that. How about to read? You already know how to read using scanner. To read from where? Keyboard, system.in. Instead of system.in, you just provide a file name. And the rest is the same. Next line, then you read in line by line. So just switch the parameters from system.in to the file, and we just talk about the file, right? That you want to read from. And all the methods are the same. And you already know how to do that. So like for example, you create a scores file and then you just use scanner and pass file instead of system.in. Now you can use while input.hasNext. You can read all the text file in here. You can just say input.next. .next always stop at the white spaces. Right, first name, middle name, last name. You pretty much just read everything in, and don't forget to close. Input.close. That makes sense? Now the same thing. You can surrounding with try catch, then it's going to close it for you automatically. So this is just showing you the program study, right? Case study. Replace text from source file to the target file with the old string to a new string. Okay. So it's just showing you how to write a code for that. So you already know that ARGS, string ARGS, this is where you provide a parameter when you run at the console, right? Compile the program. So just this is read in the parameters, and then just check source file from the argument 0, right? Target file from argument 1, and now start to pass the source file as the read in and target file as where you want to write to, and then input has next. While still have the input, then you keep reading and put in S1, and S1 you want to replace all of the arguments from 2 to 3 because the arguments pretty much is passing in the old string and new string, right? So you replace the old string to new string because you keep reading in, right? Keep replacing it and put to S2 and write S2 to the file. That's pretty much how you replaced the program, right? Alright, so this is come to some of you want to do the project with the web crawler. So technically you just reading data from the web, right? So how do we read data from the web? So a server has what we call web server, and a client we have web browser like IE, and we have application program, right? And they're connected when you request to internet to the web server. It's pretty much just exchanging the files, right? And take the file from the local file server, post it, send it back to the client, then you see images. And that file technically is like an index.html. That's the default homepage file, right? And then you can just create a URL to link to that location of the file to the internet. So now if you want to read the contents, this program pretty much just you want to read from the URL, then this one use scanner and pass in system.in, pretty much try to prompt you to enter the URL where you want to read. After you put the URL where you want to read, like can be from Yahoo for any sites, right? So it start to initialize, create the URL, and then did you, instead of what file, it's just a URL.openString as the parameters of the scanner. And the same thing the rest, if input has next, use the method of the right has next, then you just keep read line and concatenating it, right? So this one actually is just count, do the count and keep adding line of length, adding how many lines, right? Next line, and print the file size. But if you want to read the contents, you just do, instead of in, you can do like this is the contents, right? And then you can just look at string. Now when you do the web crawler or the search engine, they pretty much just gather all the database and organize them, right? Then you just look at the keywords that map to that. When you do search, it's just mapped to which the next class you learn the structure, how you can do efficiently map and get return a result back. Then you create your own google.com. That makes sense? And that's your final project, smallgoogle.com. I mean, before Google created Google, they are a computer science student, right? And they happen to take a class and happen to think about it and make it. They have a small Google first version running on the campus. It's actually, the concept is already there, right? It's just how you apply it. That's why imagination is, that's what Einstein said, right? That's the most difficult, right? Imagination, not the intelligence, right? Intelligence you can learn, but imagination, how can you have that? Like this thing learn. Right? When they make Google, they all have the same student learning, but one has imaginations to make Google. The concept is there for a long time. But do you guys see how to make, right? Well, I just say that. Do you have an idea how to make that search engine? It's just this concept. Open, put a column, get all the text, put in database, right? I mean, not the best Google, but it's sample demo version, right? And then next class you learn the structure, how to organize the data that you have, how to search and return it fast in 202. Like this session 202, I try to make them do like something, a small version of Facebook recommendations, do the network of graph of people. One student said, I'm sure that no other professor will assign project like this. Right? But he said, I'm glad that you have the video showing us how to do it. So this is just the concept of that, right? Web crawler. I mean, that is showing you, this is, like I said, this could be your simple project for 201 that I told you earlier already about this one, right? So if you look at one more time, get a URL, call the caller method. Caller method press create array, right? This is pretty much just the caller. What's the caller? Think about it. Caller just try to visit all the websites, right? And get the data from there. And we just see how to get the data by do the open stream, right? Read all the contents. Because all the contents pretty much in the coding in the text file, right? And then just look for the keywords. So like if I do view page source, I'm talking about view page source here, right? So this is the content. This can be the file or in text. And you just look for the keywords. Like when I search for what's this page? I was looking for finalize. So if I search for finalize, right there, then I return the page as a result. Because the content has the word finalize. Does that make sense? So now, when we come back to the caller, caller is not only visit one page. It's running all the time, right? Like now, caller is still running. Caller is just the one who collects the data for the search engine to use. Like search engine will never exist if they have no data, right? So once I correct like that's a keyword, I record this like URL, right? This is the URL for that. So I put into simple database, right? Key, like 2 columns, like the dictionary. That's it. How do you search for the book in the library? And it's so fast. The library has a ton of data. You're looking for a computer science book, you go to the computer science sections. Caller is the one who collects all the books and organize in the manner of Library of Congress, caller ID. That's it. So once you pass a keyword, I'm looking for Java programming book. You know right away where is it on the shelf on that library. Because they have caller ID, go to this section because it's the same thing here. Caller, collect all the data, and organize them in that manner. When you need it, pass a keyword, return result, google.com. You see, I just teach you how to make Google. Now it's just you who need to make time for it. And most likely, you give up already. Why? Because you like to do something else, you not enjoy this. You have something higher priority than this. Family, friends, boyfriends. Right? It's true, right? That should be the most important thing. Nothing else. And after that, then enjoy this. Do the project. Maybe that's the last priority on my list. But it should not be last, right? Friday is our test. So make sure put on your stack. Not first in, last out. Okay? Put on the top of your stack. Okay. Alright, so this is pretty much just showing you that it's going to keep creating two array lists. One is the list that you want to traverse. That means you never visit. And like pending, right? Pending. Oh, one is traverse, that means you already visited. And one is pending that you plan to visit. Like every day we have a new URL, right? Then it's just stack that I'm going to visit that. I'm going to visit that and make the content. So that's why if you want your page to go on the first, you must have a keyword on your page. And the rest is all about Google. How they have like their own algorithms, how they rank your page. So it's very common, right? Very simple. They get that idea, right? They make it, and then how they monetize that. Because in the old way, when you don't have Google, how you search for things, it takes so hard, so long, right? And we have the internet where people use. Then we have marketing. People want to sell their product online. So if I have a search engine that I'm looking to buy my iPhone, then I type iPhone, I get it right away. So that's how they monetize them, right? By the company who wants to go to first, they have adverts you have to pay for, something like that. So that links back how to get money to support your project. So same. So collect them, visit them on the visit list. Pending, that means you still want to go and visit. Right? Every day it's just like that. Caller just collect the new domain name and keep visited or not visited. Then we need another class that to do the organize that. And then that's pretty much it. Okay, so we finished that. Easy? Just need to practice. Last chapter. Last chapter is 17. So 17 is file too. We talk about text file, right? But this is about a binary file. Like what? Every file, if text itself is actually converted to what? Binary. Because that's the only thing that machine understand. So let's look at, you create a program, like you create a class. Like what class you create? An account, bank account class, or person class, or circle class, right? So it's going to be in a binary format. You can output, remember when you do geometric circle or circle a circle as an object when you instantiate it, right? It is an object, right? You could output that whole object directly to the file. Make sense? Like, let's say I have an array list. I push all the list of the URL, right? We've seen that, right? Where would I store it? Because normally, currently it's still on the RAM, right? Correct? When you turn off the machine, it's all gone. You have to start over again. Just like when you write application like user login information, if I ask you to create user to sign up account, after you sign up, you turn on the machine, it's gone. When you start the machine, you try to use that sign up account login password, it never exists because it's in the RAM, right? Is it better that you can just write to the file after you create, right? So that object of user you can push into a list, array list of users, right? And then you just write that to the file right there. Store it as a binary file, right? Now you turn off the machine, next day you come back, you just read the file back into your application, so it's probably in your RAM. Whenever you search login, then we have the record. That makes sense? That makes sense? So that's why we need this, right? So that's why we need to understand how to use the binary IO here. I mean, you could use text, right? You could write the user by text, but the problem with text is it's going to take longer. Why? You have to spend time to encode and decode it, because this text file is you have to have in a format that human can read. But that type of object file, you don't need that format because human is not going to read username and password when someone try to log in. We want the machine to authenticate, right? Machine is the one who's going to read exactly the binary file to authenticate it. If the password is 199, it's converted to binary like that. Why we want to spend time to decode and encode it again? Since the machine already talk into binary language already in the program. That makes sense? So that's why we want to use the binary file here. So now how to read and write the objects. That's it. Alright, so pretty much we need input stream and output stream from the API, Java API. So, and most likely, yeah, they just use this. I see JavaScript use that too. Okay. Input stream is common keyword for that. So when you want to read something, when do you want to read, like I said, you turn on the program, you want to load student information. So you read. You can do file input stream, data input stream. If you talk about filter, right, buffered input stream or object input stream. If you want to read object, right, get object input stream. If you want to write object, use object output stream. And then you can use file output stream to write to a file or to read in the file. So let's look at the method is just read, right? If it's available, and then close. So those are common method. Output just to write, and close. Flush, flushes this output stream and forces any buffered output bytes to be written out. So this is to show you the hierarchy, right? So we just have adding more method file constructor, right? File input stream, file output stream here. So let's look at an example. So if I want to write something, I need to do file output stream. I want to write a file, right, in this case, and then just create a file name. So .dat just stands for data because it's binary now, right? Like binary means 0110. You write it like that. So this is a file that I want to write to. I name it temp.dat. What do you want to write to? If I want to write just all the numbers 1 to 10, just output a write. That's it, right? So if I want to read in, remember this has to surround by try catch, okay? Same, create a file input stream. What you want to read, temp.dat, and then you print out what you read in input.read. So it's print, right? You write to this file, loop it, you print out what you wrote. Easy. All right, so now they have data input stream, data output stream. So pretty much if you want, just like scanner, you can do next int, next double. So if you want to specify, like you want to read boolean, read byte, read short, right? Like read from the file, right? From where the binary file. Write, you can write specific data type to the file too. So let's look at an example. Same. Now I'm not using the file output stream, right? Or in file input stream. I'm using the data output stream. Same file. So now instead of output.write, I just be able to specify the type of data that I'm writing to. Double UTF is like uniform, right? It's like a standard format UTF-8, right? Text format something. Okay. Same. Now when you want to read, you can just do the same type that you want to read in. Read UTF like John and the values in. That makes sense? Okay. Now so this is just showing the file input stream and file output stream that we used before. It's just dealing with the binary itself. But now if you just make it more into data, then it's going to deal with the data type. Make sense? That's the difference here, right? So we also want to see how we're going to detect is the end of the file, because sometimes you actually want to keep reading until the end of the file, right? So we have how we gonna write that. So we can use try catch to help. So in this case, like for example, we write the file, right? And then we have data input stream. We keep reading while it's true. Instead of have to read by line, we can put in a loop right away. And we can just read double, right? So we set it while it's true. That means it's going to keep reading, and then when it reaches the end of the file, it's going to throw exception end of file, because it's no longer be able to try that, right? So that's why we're going to throw all data will read. That's one way to do it. Just use the try catch to help. Alright, so now let's look at buffered input stream and buffered output stream. So buffered can be used to speed up input and output by reducing the number of disk reads and writes. So just like when you send information to the printer to print, we can have a lot of people send it to, right? But printer have to queue one by one. Where would it go? In the buffer. So it's just create a temporary storage, right? To make it faster to read and write. Okay. So program now no longer read from the actual, it's just read from the buffer, right? And write, also write to buffer, and then once it's done, it's just write to buffer once. Then make program faster. Instead of connecting to hard disk directly or RAM directly, it's going to take time, right? So to use buffer output stream, we have a constructor. just provide the output stream that we have seen earlier, right? So case study to use, okay, copying files, right? So I want to copy like welcome.java to temp.java. If you look at this is like more like Unix command, right? cp copy from target to destinations, right? But this is Java program, right? And you know, program is pretty much writing like operating system just from the program. So we create a class name copy. We have the main methods, right? So those IO exception mean it's not trying to handle here. So whenever you use the file input stream, output stream, things like, you should do IO exception. Okay, try catch. Okay. Now this one is just those, right? If arguments length not equals to 2, this is just checking, try to read the arguments, right? Argument 0 is the source file, right? Argument 1 is the destination file. Now we get source and destinations. So start to do this. We create a buffered input stream and read the whole file there into the buffered. And the same, this is going to be the target that we're going to write to. This is the file that we want to write to. So now once we have that, we start to pretty much just while input.read, right, not equal to -1. So that means we still have file contents to read, right? So we start to write to the buffer. And then keep doing that, and then that's done, right? And then we just keep counting how many we just write. So that's why I just write, okay, once done, just exit and print. Number of bytes have been copied. It's count by byte, right? Because at the end of the file, it's going to be -1. Ooh, that means it's going to exit. All right, so we learn again, file input stream, file output stream. That 1010, right? And then data input stream, data output stream when you do primitive type, right? And buffered. This is just buffered, right? When you want to speed up, you just do like a buffered, right? Make the program read and write faster. What's the object then? This is the object that I'm talking about. Like if you want to create an object of student and you put in the list, array list, you can write the whole array list into the object because everything is objects. Or the URL that you visit, right? Traversed, you can write into object. So this is where you want to use object input stream, object output stream, classes. Now, the key thing is the object must be serialized, so it has to implement serializable interface. You may have that on the test. So serializable interface is an interface that has no methods, but it's going to mark the class. Like for example, if you want to write a circle, let's see, you have here serializable interface. Like class C or class circle, you have to implement serializable. Like public class circle implements serializable. So like I said, you don't have to implement any methods, but it's just marked that this is JVM. We'll know that this is to write to the file. Now we also have the keyword transient. So this is just pretty much just a keyword to tell JVM to ignore. You don't want to write that. Like serializable tell JVM, I want to write everything. I want to ignore that. I am not going to write that. You can just tell that. That makes sense? So once the class marked as serializable, then for example, you can write the object now. So I have an array of numbers. I have an array of strings name. These are objects, right? So object output stream to the file output stream. This is the file name. When you mark parameters, this is the file name. When you have second parameters, that means you allow it to append to true instead of replaced. So you can do output.write object right there. The whole object, numbers and string being wrote to the file as appending. If you want to read them all back, just do object input stream. And parameter is new file input stream, the file that you want to read in. And then you just do dot read object. It's the first one returned as an array. That's why you want to cast back. Alright, of integers. The second one we read in, we wrote the second one string, so cast the string back. And if you loop to display, you get the object back. Okay, that's how you use object input stream and object output stream. It's very useful when you want to store the data in your program, right? Alright. So random access files. I think you may have tests on this one. Okay. So now we're done with input output stream, right? So this is just about accessing the file, right? Like if this is talk about binary files to test.dat, you can read and write, right? So you create a file named random access file, right? We will talk about file itself, right? Now this is random access file. You can give permission, read and write. Okay. So these are the methods that you can do with the random access file, right? Same clause, get file pointer. Like pretty much when you read the file itself, there's a pointer that points to the location where it is at. So that's the file pointer that you want to get. Return the offset, which is they call offset that pointer. From the beginning of the file to where the next read or write occurs. You can get the length, number of bytes in this file. You can read a byte of data from this file and returns -1. Let's say -1 always marked as end of this file, right? You can do read and provide a length, right? That how far you want to read. This you can start from where offset, right? You can specify the location you want to jump it to read, right? From offset and length from there how far away you want to read. And this is seek. That means you can actually move your offset or your pointer to the locations. You can look at this just like when you were watching the movies. You can just have that pin right on YouTube. You can fast forward, but this is fast forward to the file location. You can set the length of the file. Skip. You can skip. Yeah, skip by bytes, right? Skip bytes. How many bytes you want to skip in, right? You can also write to the file, write into the location. So look at the file again. This is all in binary, right? That's why I said if you want to read, there's a pointer. And again, the file is going to be in a byte as a unit, right? For the block. 1 by 1 characters, right? Char 8 bits, right? 8 bit 1 byte. So this is a byte, 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 byte. Now if it's an integers, how many bits? How many bytes? Integer has 32 bits. 32 divided by 8, 4 bytes. When you do read in, it's going to jump 4 blocks at a time. Make sense? Okay. So let's look at this program. You need to understand this. I think you have it on a test. So I create a file in out of that with the permission read write. I can read and I can write. So in out dot set length to 0. So that's going to clear the file to destroy the all contents that exist. So empty file. I start to write an integers, right? 200 numbers. Okay, what should be my file size? Where I say in out dot length. See, that's the test. You have to understand. You have an example like that, you should be able to tell each step. So what should be my file size? This is an integer. Integer has what? So if you don't not sure, go back. What would the length return? Return the number of bytes. Integer has how many bytes? 4, remember? And how many integers that you wrote to? 200. So it should be 800, right? 4 times 200, right? So that's why you need to review, okay? Because in the test, if you don't understand this, you're not going to get it. So now we set in out.seek 0. Remember we have the pointers, right? This pointer, we move it to the beginning. It says 0, right? I wrote it. This one at the end because I wrote, right? Now I have to reset it by moving in the beginning. Correct? So now let's go to 0, which is in the beginning. In out.readInt, what should be the output? Read in and read 4 bits, 4 bytes, right? At the time. What should be? The first number, right? Which is 0, right? Right? Because we loop and we write 0, 1, right? 2 to 200, right? Any questions so far? Alright, so I do seek. I move my pointer again. Seek is the command to move your pointer, right? 1 times 4. So and don't forget that when I do read, my pointer is now where? At 4, like around there, right? And then I said I move it to 1 times 4. Okay.
So did you need to seek it, or could you just have left line 23 out if the pointer was already there?
You don't have to. You can just, yeah. But this one just try to, yeah. So meaning, technically it's just moving to the same location I left, correct? I didn't do anything actually because I was there, right? Because it's still at 4. Now I read the second number, which is 1, right? So it should be 1 right there, right? So now come back, it's say 9 times 4. So meaning that what? If I do 0 is the first number, 1 the second number, 9 is the number 10, right? So it should return number 10. Since we start from 0 to 9, it should return what? 9, right? Because 9 is the number 10, right? Because we start from 0. Alright, now we write int 555. You see, I never use seek. At number 10, after I do seek read, it moved to location. It replaced number 10 with 555. Correct? At number 10, it's been replaced with 555 because I didn't move the seek, right? Pointer. Now it say in out.seek in out.length. Now I move to in out.length is at the end, right? So I move my pointer to the end and I write 999. So what should be the length now? It was what? 800, then 804. Because 4 more, right? This is an int. Make sense? And now I move back to location number 10. Let's remember I replaced 10 with 555. Now I print, I have 555. That's what you need to know for the test. Okay? Any questions? So if it's double, it's going to be 8 bytes instead, right? If it's char, it's going to be 1 byte at a time. Okay, just depend on the data type. Okay? Alright, so that's it. We did 3 chapters in 1 day. Hopefully it's not too much for you, but we make it. Alright, so we covered everything. So your class exercise for discussion, right? Assignment for this Sunday is going to be what? Everything else that we haven't done. Okay, if you haven't done 13, 12, 17, and 19, please submit them. Okay? Technically, 19 you need to do. Say that again.
I was adding on. Anything else you have not submitted?
You have 5 days for that, right? 5 days is the period from the due dates. Alright, so
Can I ask you, is it okay if
I think we're done. Let me